Okay, so this week we're going to talk about Chapter 9. I've cut and pasted some different things so that way this will be a little bit more smooth. For the most part, everything we're going to do in Chapter 9 is using a graphing calculator. If you don't have a graphing calculator at home, you can download the app Calculate 84, which is what I have over here on the left side of my iPad. And this will do all the functions that we need for this chapter. Or if you go to your manager on your laptop, you should be able to download a free trial of Texas Instruments graphing calculator. So that would give you the calculator that we have in the classroom available to you as well. Okay, so Chapter 9 is about correlation and linear regression. So this section will allow us to describe what type of relationship or correlation exists between two quantitative variables and how to determine whether the correlation is significant. So a correlation is simply a relationship between two variables. So here below we have 4 different pictures of various types of scatter plots. A scatter plot can be used to determine whether a linear correlation exists between two variables. So as x increases and y tends to decrease, this is called a negative correlation. As x increases, y tends to increase. That's going to give you a positive correlation. The scatter plot that has all of our points not really in a line at all, just kind of spread out, is going to be no correlation. And then our last one that looks almost like a parabola, that's going to be a non-linear correlation. So it has some type of correlation, but nothing that we want to use. Alright, so when we're constructing a scatter plot, we are going to want to, so we have, let's see here, number of years out of school, X, and the annual contribution in thousands of dollars, Y. So normally when you're doing this, you're going to draw and label your X and Y axis. And you're going to plot your points, okay? But we're going to use technology to do this. So you're going to go into the graphing calculator. You're going to go to Stat. And I think mine are actually going to be in here. Edit. Yep. So you're going to put all of your X values in L1 and all of the Y values into L2. And then you're going to go to second, Y equals, see how it says stat plot. And you want to make sure that you are, oops, I don't want to change color, on. Okay, if you have the color edition of the graphing calculator or you have the app, you can change the color however you want to see your graph. Okay, if you were going to do scatter plots, so we want points. If you want to change the way it marks it on the graph, you can. I'm just going to leave it the way it is. And then your X list, make sure it says L1, and your Y list L2. And then go to zoom, which is the third option. And we're going to always want to use zoom stat. And when you do that, it will bring up your graph where all of those points are at. Because otherwise, if you don't, and you just plot, hit graph, you're not going to be able to see anything but maybe a couple. So whenever you hit zoom stat, it will always give you the picture of your graph that you want to see. So from this, we can see that we have a bit of a negative correlation. Alright, so from that, we can find a correlation coefficient. And a correlation coefficient is a measure of the strength and the direction of a linear relationship between, I'm running around a room, two variables. The symbol R represents the sample correlation coefficient. So a formula for R is R equals N times the summation of X times Y minus the summation of X times the summation of Y divided by the square root of N times the summation of X squared minus the summation of X squared, and that's times the square root of N times the summation of Y squared minus the summation of Y quantity squared. Okay, so where N is the number of pairs of data, the population correlation coefficient is represented by rho, which looks like a kind of like a curvy P. Okay, and that's our Greek letter rho. So the range of correlation coefficients is -1 to 1. So the closer to +1 means we have a strong positive correlation. Closer to -1 is a strong negative correlation. And the closer to 0 represents no linear correlation. Okay, so rather than using this formula that most of you have kind of probably checked out now, we're going to just use the graphing calculator for it. So if you're using your own calculator, you're going to have to do a step. You're going to go to second and then 0. And I can't show you on this calculator because it's not going to really let me, but 0. And there should be, it says catalog. Okay, and it's going to give you a giant list of options. You're going to hit your down arrow until you see diagnostic on. And then you're going to hit enter. I think you have to hit enter twice. And that will turn it on and allow you to find that correlation coefficient. If you're having any issues with it, send me an email. Okay, if you download this app, it will already give us what we need. So when you're finding the correlation coefficient, we're going to type X values into L1 and Y values into L2, which is what we've already done with our making our scatter plot. Then we're going to hit second quit. Then you're going to go to Stat, go over to Calc, and then we're going to use number 4, ln reg ax plus b. Okay, with this, make sure you have L1 and L2. Something that we'll come back to the store reg EQ in a little bit. Okay, but then go ahead and just hit enter. And notice it should give you R equals now. So this is the data we use here. So this R equals 0.908. Okay, we're going to round to 3 decimal places. Make sure on your homework you're reading the whatever it says underneath the problems to see what form it wants you to, or what rounding it wants you to do. Okay, so if our correlation coefficient is 0.908, we can conclude we have a strong positive correlation. between the number of years out of school and the annual contribution. Oops. Okay, sorry about that. I noticed there was a mistake. So, remember when we looked at our graph, we had a negative correlation. So it looks like if you are using this Calculate 84 app, when you calculate your correlation coefficient, it is going to always give you a positive for your correlation coefficient. So make sure you're looking at your scatter plot, because this should be negative 0.908, making this a strong negative correlation. Okay, sorry about that. So once we figure out what our correlation coefficient is, we can test to determine whether or not there's a significant correlation in terms of the population. So in order for a correlation coefficient to be significant, its absolute value must be close to 1. To determine whether the population coefficient rho is significant, use the critical values given in Table 11 in Appendix B. So this is on page 22 of your tables. Okay, so we're going to use this right-hand column, okay, for our critical value. So, I'll jump back to where we were. Oops. Okay, so when we're using this table, the first thing we're going to do is we're going to determine n. The number of pairs. Then we're going to identify alpha, which remember that will always be given to you. And then you're going to find the critical value. From Table 11. And then you're going to be able to determine, so if the absolute value of R is greater than the critical value, then the correlation coefficient is significant. And lastly, you're going to interpret the decision. So this is similar to our hypothesis testing that we did last unit. It's just going to be a little bit briefer. So using the value of R from the previous exercise, so we found R equals negative 0.908. And we're using alpha equals 0.05, and we had 7 ordered pairs, so n equals 7. Is there enough evidence to conclude that there is a significant correlation? So we know that our absolute value of R equals 0.908, and then we're going to jump to that table, maybe, there we go. So 0.05 and n equals 7. That means that our critical value is 0.754. Okay, so that absolute value is clearly greater than the 0.754. So that means we can say at 5% level of significance, there is enough evidence to conclude there is a significant correlation between between the x and y values. Okay. All right. So now that we know that there's significant correlation, we have a couple of things we can then find. So the first thing we're going to look at is the coefficient of determination. So once we've calculated R, the square of its coefficient is called the coefficient of determination. So this is going to just simply be R squared. So it's important that you interpret the coefficient of determination correctly. For instance, if the correlation of coefficient is R equals 0.9, the coefficient of determination is 0.81. This means that 81% of the variation of y can be explained by the relationship between x and y. So, the correlation coefficient for the hours spent studying and the test scores data as calculated in previous notes is R is approximately negative 0.908. Find the coefficient of determination, and what does this tell you about the explained variation of the data? So here's what's nice. If you look over at our calculator, it already gives us R squared. So you can either take R squared equals the negative 0.908 and square it, or we automatically know that it's going to be 0.824. Okay. So we're going to change that to a percent. So we can say 82.4% of the variation between studying and test scores can be explained. And then the complement of that, so if we take 100 minus 82.4, we get 17.6%, and that is cannot be explained. All right, so that's the first thing we're going to do with our correlation coefficient. The second, because we've determined that there is a significant relationship between our x and y values, we can then find a model of that best fits the data. This is called a regression line, and its equation can be used to predict the y value for any given value of x. So a regression line is also called a line of best fit. And so it is the sum of the squares of the residuals, but we're going to ignore that part. We're going to make it even simpler. So what's the similarities and differences between finding the equation of a line in algebra and statistics? So in algebra, we only needed 2 points. And in statistics, we're going to use multiple points. Okay, the similarity is we're still using that equation y equals mx plus b, where m is the slope and b is the y-intercept. So the equation of a regression line for an independent variable x and a dependent variable y is y hat equals mx plus b, where y hat is the predicted y value for a given x value, the slope m and the y-intercept b are given by the equations. So m equals, we have a quotient. So in the numerator we have n times the summation of xy minus the summation of x times the summation of y. And our denominator, n times the summation of x squared minus the summation of x, quantity squared. And then b, or y-intercept, is given by y bar minus m times x bar. So remember, x bar is just our mean, so y bar is the mean as well, so the summation of y divided by n minus m times the summation of x divided by n. Okay, so again, where y bar is the mean of the y values in the data set and x bar is the mean of the x value, this regression line will always go through the ordered pair x bar, y bar. But instead of using this giant formula, we are just going to use the graphing calculator. Okay, so I realize that now that I'm saying this, our x and y value, what they represent, keep changing between the number of years out of school and annual contribution with studying and test scores, so I apologize for that. So, back to this original one. A director of alumni affairs at a small college wants to determine whether there is a linear relationship between the number of years that alumni have been out of school and their annual contributions. We did this, okay? Find the equation of the regression line for the number of years out of school and the annual contribution. So, in your graphing calculator, you're going to make sure you go to Stat Edit, and we're going to do in L1 our x values, in L2 we're going to do the y values. So we've already done this step. And then we're going to go to Stat, go over to Calc, and then go to number 4. Lin, Reg, AX plus B. Okay, so I still have that on my screen over here on the left. So notice it says y equals AX plus B. So here your A is your slope. So we can say that y hat equals negative 0.380x plus 12.876, because we're always going to round to 3 decimal places. So that is our linear regression. Okay, so remember our correlation coefficient was negative, and from our scatter plot we could tell it was negative, so that's one way we can see it. One thing that will help you on your homework, so I'm going to go back to Stat, go to Calc 4, where it says Store Reg Equation. If you go to VARs, that's just underneath your arrows, and you go to YVARs, using the right arrow, hit enter, and then hit enter. What it's going to do is it's going to store this equation for y equals ax plus b, and if you go look at your scatter plot, it's going to draw that regression line through your scatter plot, and that will help you on a couple of your homework problems when they're multiple choice and you're trying to decide. That way you don't have to do the problem 18 times. For those of you that like to guess. Okay, so once we know our regression line, we have an application. So after finding the equation of a regression line, we can use the equation to predict y values over the range of the data if the correlation between x and y is significant. We found that it was significant. The key thing here is we have to have over the range of the data. So these are all going to be x values. If any of these x values don't fall in our range of the x values that are given in the table, then it's not meaningful. Okay, so if we look at 7, So 7 is in between our range of 1 and 30, so that's good. So you're just going to simply do y hat equals negative 0.380 times 7 plus 12.876. Or you can go to second table. Actually, let's change our setting. So second window, we're going to change this to be ask. And then go back to your table. Why didn't it save it? Okay, well, it should let you ask. I'm not sure why it's not. Okay, but anyways, if you have your own graphing calculator, you can just do second table and be able to type in each of these x values. But when you do this, you're going to get 10.216. Okay, 40 years. So 40 doesn't fall between 1 and 30. So this is going to be not meaningful. So we can't go any further. We can't use our equation. And for 23, y hat equals negative 0.380 times 23 plus 12.876. And if you plug that in, you get 4.136. Okay, and then the last part is just that video. Okay, so if you have any questions, make sure you pop into a Zoom call or send me an email.